Okay, everybody, please put on the pencil and pen. So we are finished the 5 minutes calculation. Okay, so hello, Margaret. You're using the phone. Yeah, just to ask your mom to try to open the computer or turn on the computer, okay? Haven't seen you for a long time.
老师跟你讲话，
How are you?
跟你讲话。
Yeah, I'm talking. Hi. Okay, so everybody, please count how many questions you did. This is pretty hard, right? Okay, the number gets bigger. Hi, Gordon. Yeah. So send it to me by chat. Oh, Gordon, good job. You finished off. Amazing. Okay. And Margaret, you're late, so don't worry about it. If you want to keep practicing, I can send your mom some like the calculation sets, okay? No, Luciana, it's not slow. It's really good because the number is big and it's getting harder. And don't forget, we have been off class for 2 weeks and everybody get a little bit off, right? So it's normal. Okay, Gordon, and Era 101 exec codes and whatever. Yeah, so Oliver, did you send me how many questions you did? Okay, thank you, Oliver. Pretty good. Okay, everybody. So we're going to just focus on the last week's homework first because I just to check some of your homework. I think not really that fantastic that I think. Okay, so we just take a look at hey, all of you, do you mind just to turn on the mic because I feel so weird, like it's only me is talking. Okay, Ali, Gordon, Oliver. I think Margaret's really good. Thank you, Margaret. Okay. And everybody turn on the camera and turn on the mic. Gordon, what are you doing? Yeah, turn it on. Okay, so yeah, at least I'm hearing you are doing something, right? I don't care. I'm not like those teacher I want like precisely everybody is so cool and nobody's talking. I don't want this. Okay, so let's take a look at the problem one. I show you the solution, of course, but I'm going to explain why the answer is like that. Okay, so first of all, the question is want to ask the sum of the area of the triangle cut off then this one, right? Oh, so you know what? I need to do everybody having your homework like handy. So we need to have the original question first, I think. Yeah, this one, okay. So 1 second. Do you have your own page of so 1 second, I just to go back to the homework and just to get it for you first. Let me see. You know what? I just scan it. Give me 1 second. Two of them first. A second. I just do two of them, then we just little by little. Sorry, it's very slow. Okay, so let's just take a look at can you see it, everybody, the question? Okay, so an isosceles right triangles is removed from each corner of a square piece of paper. Okay, so what does it mean, everybody? So we need to take a look at this question. I feel like there are a lot of students, they don't understand what is thing, okay? So this is a square, okay? It's a 正方形, understand? So when you have a square, that means each of the side is the same, right? So an isosceles right triangle has been removed from each corner of the square. That means these two lines are the same, and these two lines are the same, right? Because it's an isosceles triangle, right? And it's a right isosceles triangle. So obviously, these two are right angles. And these two lines are the same, and these two lines are the same. And these are our what? Our right triangles. Oh, sorry, yeah, right triangles as well. Correct, everybody? Okay, so obviously, we don't know the size of the isosceles triangles. There are obviously two data, so I can just name this one A and this one B. Can we do that? Gordon? Okay, so I just named this one A, and this one A, and this one B, and this one B, right? So the removed triangle are shown as a gray in the picture, so I'm sorry. So we can just have them like that. I know on my page doesn't show, but you can see it is like that, right? So the removed for the sum of the area of the triangle cutoff is if the length of the diameter diagonal is D. Is 20 units. Okay, so everybody, let's take a look at this one. So how do we do this? We want to know exactly what is the sum of the area of the triangles has been cut off from the length from the triangle, sorry, from the square, right? So first of all, we only know the diagonal of the rectangle, right? So how do we do it? You don't know that? Okay, so we can take a look at this one because it's a right isosceles triangle. So we can take a look at this one. So Luciana, could you please tell me what is the measurement of this line?
A squared plus b squared, then like
Very good. A squared plus a squared and square root, correct? Okay, so this one, what is this one? So I'm just to change to another color if it is purple. So what is the measurement of this one, Gordon?
B squared plus b squared and then square root.
Okay, oh, Margaret has been dropped off. Okay, because that means this one is what is b squared plus b squared, very good, and square root. Okay, so 20 actually equals what? So 20 squared is actually equals a squared plus a squared and I squared plus b squared plus b squared and squared. Correct, everybody? So, oh, who is having such a big echo? Okay, so it's 400 equals a squared plus b squared and plus b squared. Correct? So now we need to find out how to calculate the area of them. So the area of the purple part is b times b divided by 2. But we have two of them, so it's b squared, right? And how about the black one? The black one triangles, what is the measurement of them? What is area? So it's a times a divided by 2. But we obviously having two of them, so it's a squared. Right, so obviously the triangle has been cut off is a squared plus b squared. We already know 400 equals 2a squared. Oh, I hate this one. 2a squared plus 2b squared, right? So a squared plus b squared equals what? Equals 400 divided by 2 equals 200. So the answer is D. Understand? So when we're doing this question, we're doing nothing. We're using nothing but the Pythagorean theorem. Understand, everybody? Okay, for this question, I think a lot of students are making mistakes. So let's take a look at this one. ABCD is a square of area 1. What does it mean? If it is a square and with the area 1, so AB equals BC equals DC equals AD, which is 1 as well. But it's 1 what? It's not saying area of 1 centimeter square or area of 1 kilometer square. So we just say it's 1 unit. Everybody? Okay, so EF and GH area parallel to the diagonal and divided the square into 3 regions of this equal area. Okay, so that means EF and DH cut the square ABCD into 1, 2, and 3. And these 3 parts are equals to each other. Get it? Say the square into 3 regions of equal area. Find the length of the EF. Okay, so in order to know that 1 equals 3, Luciana and Ollie and Gordon and Oliver, so we know that AE must equals GC, correct, everybody? Because 1 equals 3. Do you get it, Gordon? I cannot hear you.
Yeah.
Okay, good. Okay, so that means if we have BD connected, so BD is what? BD is diagonal of ABCD. I connected BD. Sorry, my pen is not very smoothly. Okay, and I'm just doing AE equals AF equals A. Can we do that? Okay, so equals A. So we know that the shaded area has been cut into 1/3, correct? So triangle AEF equals triangle CGH must equals to 1/3 of the square ABCD. Correct, everybody? Okay, so we can calculate the AEF equals what? Equals A times A divided by 2. Right, so that means A squared over 2 equals 1/3 of the rectangle, sorry, a square ABCD. So we know square ABCD should equals to what? Equals 3A squared over 2. Correct, everybody? But we know that square ABCD equals the area of 1, correct? Okay, so that means 1 equals 3A squared over 2. So A squared equals what? Equals 2/3. Okay, I'm gonna stop here, let you think about it, if everything is still making sense. Okay, if you want to take in notes, that's the time for you to take notes yourself.哎呀，你们要这个 AI 有什么用呀？ Okay, got it, got it. Okay, understand everybody? Okay, so we need A squared, so what did we? So 2A squared equals 4/3, correct, everybody? Because 1A squared equals 2/3 and 2A squared equals 4/3, right? So we have EF squared equals AF plus AE squared, right? Because they are Pythagorean theorem, correct? Okay, so EF equals what? EF equals A squared plus A squared and square root. So exactly 2A squared square root equals 4/3 square root. So equals 2 and square root 3/3. So the answer is E. Okay, so let's take a look at number 3, okay? So find the ratio of the area of the square that circumscribed and inscribed a circle. Okay, so let's take a look at this one. So what is the ratio of the area? So let the diameter of the circle be D. Okay, so I'm going to just ask you to connect this one. Okay, Luciana, so this one is a diameter. Understand, Oliver? Understand, Gordon? Okay, so this is D. Okay, the area of the square that circumscribed the circle is A squared. Is D squared. Yeah. Why is D squared? Ollie, do you understand? Okay, let's take a look at this one. I used a different color, okay? So, let me see. So, Luciana, if I want to calculate the area of this little purple square, so how do we do it? Okay, you can see if I name this one as x, this is x as well. So x squared equals what? X squared plus x squared equals d squared. Right, because it's a rectangle, sorry, it's a square. So it's a right triangle. So Pythagorean theorem, x squared plus x squared equals d squared. Am I right? Okay, so in order to find out the so d squared is actually, so we need to see x times x equals x squared. So the area of this one is x squared, right? So we have 2x squared equals d squared. So x squared equals d squared over 2. Correct, everybody? Okay, so let's take a look at this one. So they want to find out the ratio of the area of the square or the inscribed circle. So how do we find out what is the area of the inscribed circle? It's d over 2 times d over 2. A circle. Oh, sorry. Do we have to do that? That inscribe the circle of the d. So we have this one as d squared over d squared over 2. So the answer is 2. So the answer is D. Okay, so let's take a look at number 4. What is the area of the intersection of the two squares showed where P is the center of the square of ABCD? Okay, so for this question, do we still need to have the shadow part or no? Give me 1 second. Yeah, so that is the area. Luciana and Gordon and Ollie, this is the part, okay? What is the area of the intersection? The two squares showing where P is the center of the ABCD. Okay, so if P is the center, what is a good thing about it? Is like if I connect with the DB, and it must go through P, right? And we can also remove this one, because if I make this one as something like that, the covered area should be the same. Okay, let me just do that. I just move it to something like that. Get it, Ollie? Okay, so if we have this one 4, this is 4, and they are the same rectangle, sorry, square. Why am I always calling this rectangle? So you're gonna find out that actually the middle one is the same because P is in the middle. So P to this one must be 2. Get it? P to BC must be 2. And because P is the middle, so P to CD must be 2 as well. So the area of this one is exactly 4 centimeters square. So the answer is D. Okay, I just realized a lot of students like doing those questions with pretty complicated method. So let's just take a look at number 5. By 9 by 11 table sits in the corner of a square room as shown. The owner designed to move the table to the position showed in the second figure. The side of the room is s feet. What is the smallest integer value of s for which the table can be moved as desired without tilting it or taking it apart? Okay, everybody take a look at this one. So first of all, I think a lot of students don't understand what does it mean, right? So what is the question talking about, right? Okay, Ali's head, yeah. It's sometimes when we're having AMC math contest, it's not only just doing the question itself, but more Leslie is talking about this question is, the meaning is very hard to understand. So let's just take a look at this one. So first of all, it's not a square table, it's actually a rectangle table. And you can see this, the measurement of this rectangle table is 9 feet by 11 feet. Okay, sits in the corner, oh, sorry. It's the corner, the square room is, but the thing is we have a table, sorry, what I'm talking about. The table is 9 by 11, get it? And the square room, this room is still squared. Get it, Gordon? Okay, get it, Oliver? Okay, so the room is still square, but the table is a rectangle. As shown, the owner desire to move the table to the position shown in the second figure. So they don't want them like to be vertical, but they want to be horizontal, right? The side of the room is S feet. So we know it's S and S. What is the smallest integer value of S for which the table can be moved as desired without tilting it or taking it apart? So that means if, that means what? That means if I move this 11 sides to the other side, they must be still big enough to fit into the table. Understand? I don't want to make this table smaller. And of course, the other thing is if you want to move this table around, for instance, if your room is exactly 11 feet, that means it's impossible for you to move it without taking apart. Do you understand what I mean, everybody? Because if you are moving this table with an angle, the room is actually need to be bigger than the actually needed. If the room is only 11 feet, Gordon, do you understand? It's not going to make the turn happen. So how do we get it? Like, how do we find out the thing? So it's like that. Okay, so this is a thing I want to, I hate this. My drawing is such a horrible thing. Okay, let's take a look at this one. Get it? You need a thing like a circle to make it moving properly. So obviously for the S, it equals 11 squared plus 9 squared, and the square root equals 202, because you can see the diagonal is very important, right? You are moving as a diagonal of the, you're using the what? A circle, which the radius is the diagonal of the rectangle. So we have 202 squared. Okay, so actually we need that much space in order to move this table to this position without tilting it or take it apart. So basically you have to see 202 is bigger than 14 squared and smaller than 15 squared. So that's why 15 is the smallest integer in order to make this one happen. So the answer is E. Get it, boys and girls? Let's move to the number 6. Okay, in order to make you get more involved, I want Oliver, could you please read the question for me? Number 6.
Given the rectangle ABCD with segment MN is shown, find the area of the shaded triangles if the area of the rectangle is 100 square units.
So could you please? Yeah, so everybody take a look at this one. Okay, so let's take a look at, oh, thank you. Okay, Oliver, good job. Okay, so let's take a look at this one. Given that, so the ABCD with the segment and then this one is good, right? I think this one everybody's making right. So we don't have to spend much more time on this one. This one, I think most of you get it right. So let's take a look at number 7. The ratio of the area of the rectangle A to the area of rectangle B when their respective altitudes are in the ratio of 2 to 3 and their respective bases in the ratio of 3 to 4, what is their ratio? This one's pretty easy, right? Luciana? So if you don't know that, you can just say the altitude, which is the height of the rectangle, a rectangle is 2 centimeter and 3 centimeter, right? And the basis could be 3 centimeter and 4 centimeter. You're just using this one, 2 times 3, 2, 3 times 4. So it's 6 to 12. So basically 1 to 2. So this answer is 8. This question should be no problem, right? So problem 8, find the ratio of the area of the inner square. So let's take a look at this one. And meanwhile, I need to just to copy more questions. Okay. This question number 9, Gordon, do you mind read it for me?
I don't see a number 9.
Oh, number 8, sorry, just number 8.
Find the ratio of the area of the inner square to the area of the outer square. The vertices of the inner square intersect the midpoints of the sides of the outer square.
Okay, everybody, could you please try to do this question? Okay, we try not to just to put everything on top of it, okay? So let's take a look at this one. Okay, so find the ratio of the inner square and the area of the outer square. So the easiest part, everybody, you can just do that as, let me just to give you a quickest way, okay? Of course, it could be use X, right? But the thing is, if you have a number, like for instance, you have like a 2 or 3, you can also use that, okay? So this is X, this is half X, very good. And this one's half X as well. So this one will be what? Will be X over 2 squared times 2. So will be X squared over 2. So square root times X squared over 2 square root. So you can just time them together equals 2 over X squared. So this one is X squared over 2. This is X squared. So the answer will be 1 over 2. But this is pretty complicated, okay? Everybody, I want you to just add 2 lines. So every question will be much quicker. Is connected this one and it connected this one. Get it, Luciana? So the bigger one is actually cut into 8 equal pieces, and the outer one is having 8 of them, and the inside one is having 4 of them. So very easy, and obviously enough, they are having the ratio of 1 to 2. Understand, everybody? So you don't have to really calculate with everything, because the axes actually make everything harder. Correct, Margaret? Okay, so Margaret, please read the number, question number 9. I cannot hear you. You mute yourself.
ABCD is a rectangle of area 72 square units. Points E and F intersect side AD. Let G be the point of intersection of the segments CF and B. The area of the quadrilateral ABGF is A cannot be determined uniquely from the given information. B is 20 square units. C is 21 square units. D is 22 square units. And E is greater than 22 units.
Okay, so everybody take a look. Okay, thank you very much. So I have seen some students already help me to just to cut the rectangle into the equal parts. Understand? So that is the way of doing that. Okay, so let's take a look at number problem 10. In the figure show, P is a midpoint of side AB. If the area of rectangle ABCD is 24, then the area of the square PCQD equals what? Still, connect with PQ. Get it, everybody? So you're going to see that actually the area of APD and area PBC is equals to D whatever Q and C whatever Q. So they're still the same area. So the answer is C. Understand? So for those questions, we don't spend more than 1 minute to solve it. Okay, number 11. Let's have Luciana read the question number 11 for me.
A point is selected inside a rectangle such that its distance from one vertex is 11 cm. Its distance from the opposite vertex is 12 cm. And its distance from the third vertex is 3 cm. Its distance in centimeters from the fourth vertex is.
Okay. So everybody, for this question, there's no graph offered, right, Ollie? So in the AMC 8, there are a lot of questions that there's no graph offered. So that means you need to graph yourself. Get everybody? You need to learn how to graph yourself. So let's take a look at this one. So obviously, the point is selected inside a rectangle such as the distance from one vertex is 11. Its distance from the opposite vertex is 12. So that means what? That means one of them is 11, the other one is 12, right? And the distance from the third vertex is 3. So obviously is 11 squared plus 12 squared equal 3 squared plus x squared. So the fourth vertex is actually equal 16. Very easy. Okay, so number 12. Ollie, could you please read the number 12 for me? Ollie? Hello? I cannot hear. Can you hear me? Can you read the question? Oh, sorry, you're sending me some message. Ollie said yes. So can you read? Okay, so please, a farmer. Ollie, I cannot hear you at all. Are you reading it or no? Your mic is not doing anything? Ollie, are you reading or no? Okay, you know what? Margaret, can you do the number 12? I cannot hear him at all, her at all, sorry.
A farmer has 60 meters of fence with which to build a rectangular animal run as shown for her cows, horses, and pigs. She wants each type of animal to have the same area. What is the largest number of square meters that can be enclosed?
Mm-hmm. So everybody take a look at this one, okay? So the 60 meters of fence, which to build a rectangle animal runs showing the cow, horses, and pigs. Right, so each of them is having, so all of them I have seen, all of us like making dots on all of them, right? So the fence is like that. So you need to calculate how many of the equal lengths are there altogether, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically it's 60 divided by 10 equals 6. So that means each of the measurement is 6. So in order to find out the area is pretty easy. So 18 times 6, which is 124. Okay, get it? So let's take a look at number 13. Number 13 is pretty easy. Why I'm doing this is so off. Weird. Number 13, Oliver, could you please read the question?
Non-congruent rectangles are placed as shown to form a large rectangle whose area is 180. The
Mhm.
perimeter of this figure is
Okay, so let's take a look at this one. So 9 congruent. So what does a congruent mean? That means all the rectangles at the same measurement. Okay, so very good, Oliver. We make the length as x and we make the length of the width of the rectangle as x and we make the length of the rectangle as y. Okay, so just to cover them all together, so the rectangle place show from the large rectangle whose area. So that means because altogether they're 20, very good. So on 180 with 9 same rectangles, so each of the rectangles should be 20, correct, Margaret? Okay, so you can see, so x times y equals 20. Correct? Okay, so thank you, Oliver is doing, it's either 1 times 20, 2 times 10, or 4 times 5. So I guess Oliver will try to use the 4 times 5 because obviously it's not a 1 times 20 like measurement, correct? So that's why the perimeter of the figure equals x plus y plus 4y times 2. No, the perimeter, Oliver, you're wrong. Oh, yeah. But the thing is, you're trying to do is x plus y times 4y equals 180, right? So that's the thing. So you can just put the 120 to 10 and 4, 5, the data inside it and to check out which ones are perfectly matched. Oh, I'm sorry. This 14 is not very perfectly. Who's sending me the message? Okay, I'm sorry, Ollie. I cannot hear you at all. Just ask your mom, maybe adjust the mic for you, okay? I trust your reading. Yeah, because like none of us can, just not me, right? Margaret, can you hear like Ollie is reading before? No, okay. By the way, Luciana, where are you going? Like I cannot even see your face. Okay, where are you going? Okay, so Luciana, number 15, your turn to, oh, sorry, number 14, your turn to read it.
The rectangle ABC contains a point P in its interior, which is 10 units from A, period. 11 units from B, not sure what that is, and 8 units from D. How far is P from C? Question mark.
Okay, so let's take a look at this one. The rectangle ABCD contains a point P, its interior, which is 10 units from A and 11 units from B. So that's the same thing, 对不对？跟前面的题目一样的，对不对？ How far is this one? So we're doing what? So A squared plus C squared equals B squared plus D squared, correct? We have this formula, so 10 squared plus x squared equals 10 squared plus A squared, correct? So problem 15, Gordon, your turn.
Given a square ABCD with each edge 2 units long and having midpoints of each edge M, N, O, and P as shown, BO and DM intersect at point X. BP and DN intersect at point Y. What is the area of the quadrilateral BXDY?
Okay, so let's take a look at this one. This question is a little bit different, right? So that means we need a lot of helplines to help us to find out those questions, how to do it. So given a square ABCD with the edge of 2, as long as having the midpoint of each M and OP, okay? So BO and DM are parallel, or intersect each other at X and Y. What is that area of BX dy? So BX dy. So we need to, sorry, not this one. BX dy. So this one. right? So in order to do this one, can we just do a line here, everybody? Okay, I'm going to cut the connect AX and do it here as well. And you have to understand, like, if I connect this one, this is also the diameter of this one, right? So in order to find out the middle one, where's my pen? So each of the colored small triangles are the same area. Do you understand, everybody? 1, 2, 3, 4, 5, 6. Why? Because ABD is a right triangle, and O is a midpoint, M is a midpoint, and we just say this one is A, B, C, D, E, F, G, M. C, D, E. Okay, we just see this E. So this E is also the midpoint. So if we're connected each of the vertexes with the opposite sides of the midpoint, we will having the X in the center and all of the triangles with the same area. Okay, so we have 1/6 times S triangle ABD, which is a half of the rectangle, equals 1/6 times AB times AD over 2, which is 1/3. Do you understand? Because the square of ABCD is which the 2 units on the thing, right? Understand, everybody? Okay, because this one is 2, this is 2, so it's 1/6 times 2 times 2 divided by 2, so that's why equals 1/3. Okay, AB equals 2 unit, and AD equals 2 unit, and CD equals 2 unit, and CD equals 2 unit as well. Okay, I have seen Ollie's nodding hands, so that's right. Okay, so each of the little ones are 1/3. So you can take a look at this one. What is the area of the middle one? It's 1, 2, 3, 4. So basically it's 1/3 times 4 equals 4/3. So the answer is D. Okay, problem 16. Problem 16, Margaret.
A rectangle is divided into 4 parcels as shown. If the areas of 3 of the parcels are 24.5, 42, and 56, what is the area of the 4th one?
Okay, so this one's pretty easy, right? We have what? We have learned the thing is because 42 times 56 exactly equals 24.5 times X, right? So we're just using 42 times 56 divided by 24.5 equals X. The value of X is 96. Okay, this question we're not going to use any more time to explain it. So let's take a look at number 17. 17 is the same thing. We just leave it open. I think everybody should know how to do it. Please, number 18. Okay, in the figure. So the figure is down below. The segment of length AB lie on the perpendiculars to the diagonals of a square of the size 2. Okay, so that means A is perpendicular to this diagonal and B is perpendicular for this diagonal and A is perpendicular on this diagonal. So on the other hand, because they are rectangles and they're right angles, so we can say that A is parallel to this diagonal and B is parallel to that diagonal. Understand, everybody? Okay, so with the size of them, and we want to find out A plus B equals what? So let's take a look at this one. So we have X equals here, and Y equals here, and we have X plus Y equals 2. Everybody understand? Okay, and because A and this one, they're the same, so we have X squared equals A squared plus A squared. So X squared equals 2A squared, and we square root it. So X equals square root 2A. So the same thing, Y equals square root 2B. Okay, so we have square root 2A plus square root 2B equals 2. So we can divide it by square root 2 for the both left side and right side. We have A plus B equals square root 2. So that is answer number B. Okay, you can stop me if you're making any part that you're not very clear about it. Do you understand, everybody? Okay, so let's take a look at number 19. I'm tired, so who can read the question for me? Number 19, Luciana, thank you.
Problem 19. ABCD is a square with AB equals S. Point P is an interior point such that AB, BP, and the distance from P to line CD are all equal. Find the distance.
Okay, so let's take a look at this one. So P is a point. Okay, so AB equals S. So everybody, please put the S on top of it. P is an interior point such that the AP equals BP. So I know AP must be a line that parallel to AD and BC, right? And the distance from P to CD, which is you make a right angle here, is all equal. The distance from T to CD and this one. So the P's interior points such as AP, BP. So AP, BP, and PC are equals to each other. Okay, so we can just make this one X, correct? Because they're equals to each other. Find the distance. So we want to find out X equals, in order to use X to represent, using S to represent X. Correct? Okay, so I'm going to just make it half. Correct, everybody? So because this one is S, this is X, so this little line is S minus X, correct, everybody? Okay, so we immediately have a relationship is X squared plus, oh, sorry, X squared equals S minus X squared and plus S over 2 squared. Correct? So we have, if you simplify this one, you have 5S over 4 equals 2X. So X equals 5S over 8. So that is the answer, number 8. Okay, so problem 20. Inside the square ABCD with the size of the length X, quarter circle arcs with the radius of X are drawn using as AB as the centers. These arcs intersect at a point of E inside a square. So the distance from E to the side CD is what? Okay, so this question is a little bit different than the other one is because they have the circles inscribed it. So, but I want you to connect it AE. Because it is inscribed a circle, so basically AD equals AE because they are both the radius of the thing, right? And you can just make the EF and G, so F and G, so with the right angle. So basically this is X over 2, this is X, and this is S, and this is X minus S. Okay, with a bit of the calculation, so we can have the answer is D. Okay. Okay, so we have spent 1 hour explaining the before homework, so we don't have a lot of time doing the new thing. So let me just focus on the today's learning part passage. Okay. So today we're going to learn the thing is called a trapezoid. Okay. Confirm your, no, my speaking language is English. Okay, so everybody, let's just take a look at this one. So meanwhile, I need to go to the washroom, right? Okay, so while I'm going to the washroom, I want you to copy the basic knowledge yourself. Okay, because we need those ones for the upcoming everything. So everybody, please copy down the thing. And I'm going to the washroom, and when I'm back, I hope you already copy the thing. We need it, okay? Okay, everybody, did you copy everything down? You're done or no? Or do I have to explain everything to you? Okay, so let's take a look at this one. Okay, we have a trapezoid. Okay, so for the trapezoid, the most important thing is they have a parallel line, which is CD and AB, right? Where is my annotation? Where is my annotation here? Okay. Annotation. Okay. So let's take a look at this one. So CD and AB are parallel to each other, and AB and CD are called the bases. Okay, so H is called the height, and ABCD are called the diagonals. AC and BD, right? So because we have the diagonals, then we have what? ABE and CDE, they are similar to each other. Okay, and also there are another similar triangles, I think is, oh no, there's these two triangles are similar. So that's why, because they are similar triangles, that's why AB to CD is exactly equals to AE to CE and BE to DE. Understand, everybody? So this is very important. You can use it directly, okay? So the base angles of an isosceles trapezoid are congruent. Okay, so these two are the same only when I tell you this trapezoid is isosceles. If the base angles of the trapezoid are congruent, the trapezoid is isosceles. Understand? 如果最下面的两只角是一样的 the angle are the same, so we can call this trapezoid as what? A isosceles trapezoid. If they're not the same, you cannot call them. Okay? When you have a isosceles trapezoid, then AD, of course, 它们这两条是怎么样？是一样的。So AD equals BC, right? And also AC equals BD. The diagonal is also equals to each other. And the base to bottom is the same. And also the top two angles are the same as well. Okay, so triangle DAB plus DCB equals DBA plus CDA. Which is equals 180 degrees. Okay, oh my God. Understand, Ollie? Okay. So let's take a look at the properties, okay? So we have property 1 in the trapezoid ABCD, sides AD and BC are parallel to each other. If AD equals A and BC equals B and AF equals H. I'm sorry. So the area is A plus B times H divided by 2, right? Okay. We don't have to prove it. We just use them directly, okay? So we also have property 2. The medium of the trapezoid, the segment joining the midpoint of the non-parallel sides is parallel to each of the parallel sides and has a measure equals to 1/2 of the sum of their measurement. So if E is middle of the DA and F is the middle of BC, and you cannot EF, okay, Margaret? EF is parallel to CD and parallel to AB. And also the measurement of them is exactly half of them. Get it, everybody? Okay, so let's take a look at property 3. In the trapezoid ABCD, the following relationship is true. So GH is equals to the half of BC minus AD. And GH is the midpoint of the diagonal of AC and BD. This is very, very important. So highly recommend everybody take this down. And you can directly use them when you have a question like asking you how to calculate the GH. Understand, everybody? Please copy this down. Okay, when you finished? Okay, G is the midpoint of BD. H is the midpoint of AC. So that's why obviously GH is parallel to AD and parallel to BC, right? And also, you just can directly use it. GH, the measurement, equals the bottom part minus the top base of the trapezoid. Okay, so let's take a look at, we don't have to look at the proof. So just use them. Oh, property 4 is very important as well, okay? The measurement of the segment passing through the point of intersect of the diagonal of the trapezoid and parallel to the basis of its endpoints on the legs. The harmonic mean between the measurement and the parallel sides, the harmonic means of two numbers is defined as the reciprocals of the average of the reciprocal of the two numbers. So let's take a look at this one, okay? So AD equals A and BC equals B. And MM equals A times B times 2 and divided by A plus 2. So please copy this down. And Margaret, how to copy this down? 先把这个图画在你自己的本子上 ，understand, Luciana? 然后再把这个公式抄在旁边，可以直接用，好不好？ Okay, so did you copy this down, everybody? Finished? Okay, so let's take a look at the property 5, okay? In trapezoid ABCD with AB parallel to CD, let the area of triangle ABO equals M squared. This one's very important as well, okay? M squared. Why am I using this ugly purple color? Let's do, yeah, red. M squared, and let's DOC equals N squared. The following relationship is true is the triangle ABCD, sorry, not triangle, the area of the ABCD, which is a trapezoid, equals M plus N squared. For instance, I'm telling you, the area of AOB is 49. Okay, the area of COD is 25. So what is the area of ABCD? It's very easy. You just do M equals 7 and N equals 5. So that's why S ABCD equals 12 squared equals 144. Get it, everybody? Okay, please copy this down yourself. Number property 5.
I don't
this
on it rolled like really far.
Copy done? Everybody-
teacher,
Yeah.
what does the S stand for?
Oh, S is area.
Oh,
Yeah. Okay, so let's take a look at property 6. For any trapezoid ABCD, the following relationship is true, okay? So if we have the area of OCD equals A and the area of OAB equals B, then SOAD, which is 像旁边两个小翅膀一样的，OK？小翅膀的这两个 area is equals to A times B and square root. For instance，如果老师跟你说啊，this one equals 9, okay? And this one equals let's say 25. So the area of S equals 9 times 25 square root equals 50. Get it, everybody? Okay, so that is how we do it. Okay, copy this down, property 6. Okay, when you finish, copy. Margaret, 抄下来了吗？有没有乖乖抄下来？因为后面的题目你都要用这个的啊。如果你这个不抄下来，后面题目一道都不会做。Okay? So in trapezoid ABCD, if ADFE 上面的那个跟下面的那个是一样的。Okay? So the upper area of the trapezoid equals lower trapezoid. Okay? Luciana? 那这条 EF 肯定不是 midpoint，对不对？如果是 midpoint 的上下不可能是一样的，对不对？Okay, the relationship is true like BC squared minus EF squared equals EF squared minus AD squared. Please copy them down, okay? When you finish copy, let's move forward. 抄下来了吗？都小朋友们，Luciana 抄了吗？我没有看到你动笔啊，你要抄的啊，不然的话后面题目做不出来。In the isosceles trapezoid，还有小朋友记得什么是 isosceles trapezoid 吗？OK，就是 AD 和 BC 是相等的，right？AD equals BC，correct？Okay, so the following relationship is true. Okay, so when you have a isosceles trapezoid, 啊，小朋友们知道这个角和这个角是相等的，对不对？ And these two angles are equals to each other. So we have a relationship as BD, which is a what? Diagonal of this trapezoid, trapezoid. Okay, equals AD squared plus AB times CD. 好，接下来了，这一条的平方，the square of BD equals AD squared plus AB times CD. Okay, when you copy this property, you need to copy exactly this shape first, and then copy this one. And when you copy this shape, you need to make sure you put this one. This one is not any trapezoid. 只有在 isosceles trapezoid 的时候，它才成立。Okay, when we are facing an isosceles trapezoid, it is working. Not all of them, not any trapezoid. Please copy them down. When you finished, please let me know, okay? 要把它都写下来。Margaret 抄好了吗？Ollie 也抄好了。Okay, 好。Let's take a look at examples, okay? So this question is a 2007 AMC 8 questions. Pretty easy, this one, okay? In the trapezoid ABCD, AD is perpendicular to DC, and AD equals AB equals 3, and DC equals 6. So based on that, we can see if this is 3 and this is also 3, right? And B is parallel to AD, and find the area of BEC. So 这个太简单，我们就不讲了啊。3乘以3除以2，so it's 4.9. This is pretty easy. 那 Lucia， 你看到2017年 MC8 的题目这么简单，对不对？好，那我们来看看2015年的是不是更简单，对不对？2015年的题目。So 2005 MC questions. So I'm going to block the answer. Please tell me the answer by chat. 好吗，小朋友们？这个红颜色有点恶心。哎呀呀呀呀呀呀呀！ Okay, everybody, please send me the answer by chat. Okay, I have received 4 message, and I'm about to open it. Very good. Okay, so I'm not going to explain this question. I think you both understand how to do it. Very good. Okay, so let's move to number 3. Let's take a look at number 3, okay? So this is a 2003 MC questions, and it's a question number 21. So I'm going to spend a little bit more time on explaining, because I think today is our last question for this class term. So the next term will be, I think, I'm not sure. So most of you are going to compete in the AMC 8 in the upcoming week or two, I think. So I just want to spend a little bit more time explaining how you're gonna do your homework. Sorry, AMC 8 questions, okay? So let's just go back to the thing. So AMC 8 math contest is containing 25 questions altogether. Okay? Each of 1 questions equals 1 point. Okay, so the maximum you can get is 25 points, which is a full mark. Okay, so unlike AMC 10 or AMC 12, there's no point is going to be offered if you leave this question blank. That means, boys and girls, you try to guess your answer as much as you can. Get it? Okay, so Margaret, for the 21 or 25 question will be really hard. You said, okay, I don't know how to do it, just leave it open. That is not a very good movement, okay? So everybody, if you don't know the answer, make a guess. If you don't know how to make a guess, just to pick a guess, just to randomly pick an answer. You say, okay, I love C the best. You just choose C. If you think this question is B, just trust your instinct. Okay, sometimes, most of the time, we have to say that actually instincts is something you can trust with. Understand, Margaret? Okay, Gordon. I know it's quite weird, right? But I'm going to spend a little bit time talking about AMC 10. So AMC 10 is a different. It's still 25 questions, but if you leave, every single question is 6 points. Okay, so that means the total full score will be 150 points. But if you leave it open, they give you 1.5 points. Yes, yes, Margaret, I know you're laughing. Why? It's because they don't want you to guess the answer. Get it? They want you to leave it open. They give you some words in order to try to push you not to guess. Understand? So based on that, think about AMC 8, the policy is being made. That means they push you. They want to persuade you to make the guess. So just to guess as much as you can. Understand, everybody? Okay. So from question 1 to 10 is pretty easy. So for all of you, I would ask you to make this 10 questions as possible to make it all right. Okay, so because none of you are grade 8 yet, so we have a very good awards. It's called, I think it's called like Yums participants, whatever. I forgot. Okay, so if you're grade 6 or under, you can compete with the young athletes or whatever. I forgot the name of that. So if you can question, you can just make it right for 14 to 15 questions, sometimes 16 questions. You can win this certificate. Okay, so let's see. So 1 to 10 is pretty easy. And you just try to make 11 to 20 as possible, as like make it right as much as possible. And 21 to 25, just a guess. I think it's not very hard for all of you to get 15 or 16 questions right. Understand, Margaret and Gordon? Okay, Oliver. So for all of you, which is not grade 8 yet, I will ask all of you to try your best to compete for the young athlete, whatever. You know what? I'm going to try to Google it. What is the name of the because it bugs me. AMC 8 young, yeah. Give me a second. Okay. So for the top one, so there's perfect scores. Okay, is for people who get 25 points. Okay, so Pang Pang used to have one time. Okay, so if you got one time like that, if you're a boy, it's not that much rewards because there are too many boys get perfect scores. But if you're a girl, you're going to be invited to United States and you will get $500 cash rewards. Yes, it's US. And you're going to be paid for the air tickets and also the hotel and food and everything. They pay you to go to somewhere else and just to give you the certificate and just to tell you how amazing math could be and how amazing a girl who is good at math can be. Okay, understand, everybody? So if you get 1%, usually it's scored like 20 to 24, 23 questions, right? You're going to get a distinguished honor roll. And if you're 5%, top 5%, Luciana, usually it's 19 to 21 questions, you get an honor roll. And for the people who's getting 15 questions right, which is under or equal to 6th grade, no matter your boys and girls, you're going to get an achievement roll. Get it, everybody? Okay, so I said if you can get 15 questions to 25 questions right, so you will get something. Get it, everybody? So that's the thing. Okay, so I want all of you to at least get 15 questions right. Gordon, understand? Okay, and if you can get more, the better, of course. Okay, so let's go back to this one. So number 3. So please take a look at this question and give me the answer. Send it to me by chat, please. I have received 2 answers. Yeah, of course you can use washroom. Uh, okay, hi, and Ollie has sent it to me. Yes, Margaret, you're right. Good job. Okay, not bad, right? But it's 2003. I wish I can go back to 2003 and do the AMC8. You know what? When I was the first time doing the AMC8, let me see. Yeah, it's a long time ago. I don't want to record my memories. So ABCD is 164. So basically 164 equals what? Equals BC plus AD. Oh, why there's no color? Oh, it's white. And BC plus AD times 8 divided by 2 equals 164, right? So basically BC plus AD equals 164 times 2 and divided by 8, so equals 41. So BC plus AD equals 41. So because AB equals 10 and CB equals 17, what is BC and in the attitude? Correct, everybody? So the answer, let me see, is 10 or 8. Let me see. Yes, it's 10. Good job. Okay. Margaret, Luciana, and Ollie, right? You're right. Okay, so let's take a look at number 4, which is the last questions. We don't have enough time to go through all of them. Okay, last questions, boys and girls, example 4. If you don't know how to do it, just to go back to take a look at all the properties I give it to you and try to find out the fitful property and use it on the question, okay? When you finished, please send it to me by chat. I wish all of you very lucky for your AMC8 questions. Unlike the AMC10, which is, do you know that the AMC10, which is happening in October, like all the questions has been slip out before the contest is even taking the math competition. Yeah, Luciana, it's pretty shocking, right? 题目被外泄了，所以 yeah, you use it or not, it's not really that very important. So, okay, so let's take a look at this one. If you don't know how to do it, you just take a look at this one. I'm going to add a line here and add a line here. Sorry. So this is 50. I don't know what it is. And this is 20. This is 15. Okay, so basically the height is the same. Okay, using a lot of Pythagorean theorems. So we have the area equals 750. Okay, so you're just using this one as x, this is x, and this is y, and you can find out the area of this one and just do that, okay? Is a positive integer, so both of them are a positive integer. Okay, so boys and girls, that's it for today's class. I'm going to send the homework to you. Okay, so I wish you're doing really good for the upcoming contest. Okay, so that's it for today's class. I wish you enjoyed it and have a nice day. Bye-bye.
Thank you.
Bye-bye.
Bye.
Bye.